Welcome to Algebra 1. The learning goal for this episode is to learn how to solve a quadratic equation in the form ax squared plus bx plus c equals 0. A quadratic equation is an equation that can be written in the standard form ax squared plus bx plus c equals 0. When a quadratic equation is graphed, the solutions will be the x-intercepts of the graph. These solutions are sometimes called roots or zeros of the equation. A quadratic equation can have two solutions. The graph intersects the x-axis in two places. One solution, the graph intersects the x-axis in only one place, the vertex. Or no solutions, the graph never intersects the x-axis. Let's look at this example. Solve x squared minus 2x minus 3 equals 0. First, we identify that a equals 1, b equals negative 2, and c equals negative 3, so the opposite of b over 2a will be equal to 1. Which means before we start graphing, we already know that it's going to open up, have a regular width, have a y-intercept of 0, negative 3, an axis of symmetry of x equals 1, and the vertex will be 1, negative 4. So we complete our table of values using symmetry to help us complete it more quickly. So our graph looks like this. We can see from our graph that our parabola crosses the x-axis in two places, negative 1 and positive 3. So those are our two solutions. Let's look at another example. X squared plus 6x equals 7. The first thing we should notice is that this equation is not in standard form. It is not equal to 0. So we need to subtract 7 from each side in order to get it equal to 0. Now we can identify that a equals 1, b equals 6, and c equals negative 7. So therefore, the opposite of b over 2a will be negative 3. That tells us that we know that it's going to open up, has a regular width, a y-intercept of 0, negative 7, an axis of symmetry of x equals negative 3, and the vertex will be at negative 3, negative 16. We can then complete our table of values using the vertex, the y-intercept, the point that's symmetrical to the y-intercept, and then two other symmetrical points. When we graph it, it looks like this. We can then see from our graph that the solutions are positive 1 and negative 7. Let's look at a third example. X squared plus 7 equals 4x. Again, it's not in standard form, so first we subtract 4x from both sides to get it equal to 0. Now we can identify our values of a equals 1, b equals negative 4, and c equals 7. So the opposite of b over 2a will be 2. So we know this opens up, has a regular width, a y-intercept of 0, 7. The axis of symmetry is going to be x equals 2, and the vertex will be at 2, 3. So my table of values looks like this. And our graph looks like this. But we can see from our graph that the graph never intersects the x-axis. So therefore, it never equals 0 for y. So we have no solutions. Now for our guided practice section, we're going to work through some problems together. You do not need to write down these problems. Just step through them with me. At each step, I'm going to prompt you the question you should be asking yourself. Then I'll pause for about 5 seconds for you to think about it and answer it for yourself. Then I'll show you. So for this problem, our first question is, what are we trying to do here? What we're trying to do is solve this quadratic equation by graphing. How do we do that? First, we must get it in standard form by adding 4 to both sides, which gives us this equation, which is in standard form. Now what? Now we identify a, b, and c and calculate the opposite of b over 2a. What's next? Now we can predict that our graph will open up, be regular width, have a y-intercept of 0, 4, an axis of symmetry at x equals 5 halves, and a vertex of 5 halves comma, negative 9/4. What's next? Next, we make our table of values. Now what? Now we graph it. What's next? Now we can see that our solutions are where it crosses the x-axis at 1 and 4. Let's try another one. What do we do first? We need to get it in standard form by adding 7 to both sides. Then what? Then we identify a, b, and c and calculate the opposite of b over 2a. What's next? Now we know that our parabola is going to open up, have regular width, have a y-intercept at 0, 7, an axis of symmetry of x equals 5 halves, and a vertex of 5 halves, 3/4. So what's our next step? Now we make our table of values. Then what? Then we graph it. What's next? Well, we should be able to see that it never hits the x-axis, so therefore we have no solutions. Now for the self-check section. In this section, you're going to physically pause the video as you work out the problem on paper in your notebook. Then you'll press play to check to see how you did. You'll have 5 seconds to pause the video after I stop speaking before I show you the solution. Please pause the video now and work out the problem, then press play to check. Here is the solution. Please compare this to your work. Pause the video here if you need more time to compare, then press play again to move to the next problem. Same thing on this problem. Pause the video, write down this problem, and work it out in your notebook, then press play to check. Please pause the video now. Here is the solution. Again, pause the video if you need more time to compare this to your work. In closing, let's review our learning goal. We wanted to learn how to solve a quadratic equation in the form ax squared plus bx plus c equal to 0. We did this by making sure our equation was in the standard form, ax squared plus bx plus c equals 0, first, then graphing it like normal. We then used what we knew about graphing to help us find the x-intercepts, which are our solutions, or determine that there are no x-intercepts, so therefore no solution.